the process of evaporation, how we define or how we explain that evaporation occur or happen. So, example, you have a container which is filled with liquid. And these are the liquid particles. The particles are in a state of a motion, they are moving. So what happened that all the particles are not having the same energy. Some particles have more energy, like some particles are moving faster, some particles are moving slower. So the most energetic particles, the particles which are having the greater amount of energy, and they're also at the surface. So most energetic particles, or the particle, how they get energy, so they take energy from the surrounding particle. So if I say this particle is having a 5 joules of energy, and the other particle, neighboring particle, is having say 4 joules of energy. This neighboring particle example having 2 joules of energy. This neighboring particle example having 3 joules of energy. Now what happened, how the process of evaporation occur? So the particles which are there at the surface, they gain energy from the surrounding. So they take energy from their neighbors. So this particle which was having 5 joule of energy, it will take some energy from a particle of 4 joule. It will take some energy from particle of 2 joule. It will take some energy from particle of 3 joule. So when it will take energy from these particles, so what happened? It is now having a sufficient energy. So this particle, when it is having a sufficient energy, it will go out from the liquid surface, and when it will leave the liquid surface, the amount of the liquid will decrease, or the evaporation will occur. And what happened to the neighbors, the particles which are left behind, or neighbors, what happened to their energy? It will increase or decrease? So that will decrease. So what happened to energy of the neighbor particles or neighboring particles? So that will decrease. So when the energy decrease, the liquid will, the temperature of the liquid will decrease as well. So that is why evaporation is known as a cooling process. When something evaporates, it cool down. Maybe you have experienced this. Like example, if you use a perfume on your skin, that part of the skin, you will feel a cooling effect. What is the reason for that? Like example, if this is your skin, a part of your skin, and even it can be happen with a perfume, even it can happen with, because perfume, the particles can easily vaporize compared to that of water. So what happened? Example, you use a perfume. So this is a drop of a perfume. So this is a drop of the perfume, and these are the particles of the perfume. Here is a skin. An example, this is a drop of liquid. Now what happened? These particles gain energy, but from where they can gain energy? So these particles actually gain energy or take energy from the skin. So when these particles take energy or gain energy from the skin, the particle will go out in the atmosphere, or the substance will changes the state from liquid to gas. So here we will have a liquid. they will turn from liquid to gas, and the particles which are left behind or the surface which is there, that surface will cool down, and that is due to the process of evaporation. And our body naturally is having this process. Like example, if you are doing an exercise or um, for example, if you're sweating or you are doing an exercise and you're sweating, so what is the advantage when you sweat? So on your skin there is a water on your skin, and this water will evaporate. As this water will evaporate, so it will cool down your body. So it's like a cooling mechanism for our body. Is it clear, the concept of evaporation and how it can be useful? Any doubt till this point? So whenever the molecules escape, the most energetic molecules will escape, and they will always escape from the surface. Any doubt till this point? The concept of evaporation. Evaporation is also refers to a cooling process. How evaporation can be referred to a cooling process? The term cooling process means when you remove the energy, that we called as a cooling process. Example, if this is your body, it's not like a shape of a body, it's just an explanation. So if there is a water on the surface, so these are the water particles. So what happened when the evaporation occurred? These water particles will escape. So when these water particles escape, originally example, the body is at 38 degrees centigrade. That's a body temperature. Like when you're doing an exercise, the temperature increases. Example, it is 38. But what happened? How the body cools down? The liquid on the surface of the body, the sweat, the particles, they absorb energy. From where they absorb energy? They will absorb energy from the body. And when they absorb energy from the body, the particles will escape, and the body will, if originally it is at 38 degree, now it will cool down to a lower temperature because the body has lost energy to the surrounding. So as it is losing energy to the surrounding, so it will cool down. That's why evaporation is also known as a cooling process. There are factors which are affecting the evaporation. Number one, temperature of the liquid. So rate of evaporation increases as the temperature increase. So if at lower temperature, like example, you have a liquid at 20 degrees and you have a liquid at 30 degree. So in which one you will have a faster or greater rate of evaporation? The liquid at a higher temperature, even if it's a temperature of the liquid or temperature of the surrounding. So even it's a temperature of a liquid or surrounding, both cases the evaporation will be, rate of evaporation will be higher. Same way, if I say the surrounding temperature is 30 degrees, here the surrounding temperature is 40 degrees. So which one evaporates faster? The liquid are originally at the same temperature, but the surrounding temperatures are different. So the greater difference between the temperature of a liquid and the surrounding, it will have a faster evaporation because more energy is available in the surrounding. That's why the particles which are there at the surface, they can gain energy or they can take energy from the environment and they can go out into the environment. Here energy is available, but small amount of energy is available. That's why few particles will go out. So rate of evaporation increases as the temperature of a liquid or the temperature of the surrounding increase. It also depends on the surface area. The large surface area, more particles are exposed, so that's why it will have greater rate of evaporation. Like here, example, only 4 particles are exposed to the surrounding, but when we have a large area, more particles are exposed, so the chance that the maybe 2 particles are going out, but the chance is there that most of the particle can go out, that greater amount of space is available. So increasing a surface area will increase the rate of evaporation as well. Is it clear? Any doubt till this point? The second factor on which evaporation depends. And the third factor on which it depends on the drought over the surface. What is the meaning of a drought? It means like the dryness. You can also use the term dryness. So if we blow the air, the rate of evaporation will also increase, because what happens when it is still air, when the particles evaporate, when these particles are coming out, so they will be there at the surface, so the particles which are inside does not find too much space to come out. But if it is a windy, if air is continuously blowing over the surface, so the particles which are coming out, they will move out away from the surface. As these particles move away from the surface, the other particles which are left behind can easily come out. That's why if you have a wind, it will have a greater rate of evaporation compared to still air. Is it clear that how the wind or the drought over the liquid surface increases the rate of evaporation? So if we increase the dryness or if we increase the drought, the rate of evaporation will also increase. Look, what happened when the particles are coming out, you have a still air. So these particles which are coming out, they are not able to move away from the surface. So as the particles are still at the surface, the other particles which are inside the liquid don't find space to come out, because the other particles are there top of them. But when it is windy, the air is blowing, so when these particles are coming out from the liquid surface, the air or the wind will move away from the surface, so the other particles have space to come out. That's why the rate of evaporation increases. The evaporation also depends on humidity. If you have greater humidity, humidity refers to the same thing, number of the particles present in the atmosphere. So if you have a humid environment, humidity is in percentage, which refers to the number of the water molecule present in the atmosphere. Greater humidity means more water molecules are there. So we have a liquid, a container which is filled with a liquid. These are the liquid particles. So what is the effect of humidity? Example, if I say we have 80% humidity and here we have 20% humidity. 80% humidity, like out of 100 molecule, 80 molecules are made up of, or are the water molecules. So already there are water molecules. at the surface in the atmosphere. When we have 20% humidity, out of 100 molecule means 20 molecules are made up of water. Which one you think will have a greater rate of evaporation, A or B? In which container the evaporation occur at a faster rate? A or B? Which one you think? Actually, it is B. Why it is B? Because already there are a lot of water molecules in the atmosphere. So when already there are a lot of molecules in the atmosphere, so these liquid molecules are not able to come out because they don't have too much space in that. There's no too much space in the atmosphere. So these liquid molecules find it difficult to come out. But because less humidity, so the particles have enough space because less water molecules in the atmosphere. So that's why greater number of the particles can come out. So rate of evaporation in a humid condition is slower as compared to a dry condition. Is it clear how the humidity affects the evaporation? That is why, like example, if you try to dry a cloth, a wet cloth, at a coastal area, you find it will take longer time as compared to a region which is completely dry. So rate of evaporation decreases if the humidity increases. And evaporation is also known as a cooling process. So evaporation is having a cooling effect. What happened? The high energetic molecules which are there at the surface, they escape. The molecules which are left behind will have low energy. That's why it is called a cooling process. Maybe you have experienced this, that why you feel cold when a wind blow over water, when a wind is blowing after swimming. So why you will feel cold? Example, after swimming, when you're coming out from the swimming pool, you will feel colder. What is the reason for that? Because the water molecules which are there in contact with your surface, they turn into vapor, they gain energy from your body, and the wind helps to increase the rate of evaporation. So when the water droplet evaporate, they remove the heat energy from your body, and that's why you will feel colder. Is it clear that how the evaporation is a cooling process? The difference between boiling and evaporation, what are the differences? The boiling, it takes place, occur at a fixed temperature, the boiling point. Evaporation occur at any temperature below the boiling point. Boiling takes place throughout the liquid, evaporation only at the surface. Bubbles are formed, evaporation no bubbles form. Then the relation between pressure and volume for a gas, how we can relate the pressure and the volume? So how the pressure and the volume of the gas are related to each other. Example, I have two containers at same temperature. Like this container is at 20 degrees. This is also at 20. Equal number of the particles are there. Which container we have a high pressure, A or B? which container the pressure will be high? Is it A or B? We already discussed this part. So that is B. So B will have high pressure and it is having lower volume. But what about A? A is having low pressure and it is having a greater or higher volume. So what is the relation between pressure and volume? When, as you can see here, the pressure is low, the volume is high. And here the pressure is high, the volume is low. So what we can say, it means if the volume increase, the pressure decreases, or if the volume decrease, the pressure will increase. So we can say if we have a fixed mass, of gas at constant temperature, if the temperature of the gas is also constant, then what is the relation between pressure and volume? Pressure is inversely proportional to volume. So what does it mean? It means if we increase the pressure, the volume decrease, or if we decrease the volume, the pressure increase. So they are inversely proportional. Is it clear, the concept, the relation between pressure and volume of a gas? So if we increase the pressure, the volume of the gas, or if we decrease the volume, the pressure of the gas will increase. And whenever one quantity is increasing, the other is decreasing. So the term which we use inversely proportional. How we can represent the inversely proportional quantity is a graph. If you remember, I told whenever the graph is there for inversely proportional quantities, so if we have pressure on y-axis and we have volume on x-axis, whenever the graph is there for inversely proportional quantities, it will always be a curve. And what it shows, you can see, if the volume is increasing, the pressure is decreasing. And if the pressure is increasing, the volume will decrease. So it means they are inversely proportional. And whenever two quantities are inversely proportional, in mathematics, whenever two quantities are inversely proportional, the product is constant. So whenever we multiply pressure multiplied by volume, what we'll get a constant answer or fixed answer. Whenever two quantity, constant answer means like it will be a fixed number according to that example. So pressure multiplied by volume, result will always be a constant, and the graph between the pressure and volume will be a curve. So how we can use this? This is known as the Boyle's law. What is the meaning of Boyle's law? Boyle's law states if we keep the volume, if we keep the temperature constant and we try to increase the pressure, the volume of the gas will decrease. So example, I have a container. This is a container which is filled with gas molecules. So 3 gas molecules are there. And I try to push this container, I try to increase the pressure. If the pressure is increased, what happened to volume? If this is a movable part, this is a piston which can be moved in and out. So when I try to compress, when I try to reduce the size, I try to increase the pressure, So what I will observe, I'll observe the volume of the gas will decrease. So increase in the pressure will reduce the volume, and we call they are inversely proportional. The equation for the Boyle's law, so what is the equation for the Boyle's law? The formula, this is very important formula, almost like every year you will find a question, that is P1 V1 equals P2 V2. What is the meaning of P1 V1 and what is the meaning of P2 and V2? P1 means the starting pressure, initial pressure. What is the meaning of V1? Means initial volume. I will solve a question, you will understand, this is not difficult. What is P2? That is initial pressure, sorry, P2, the final pressure. And what about V2? That is the final volume. I write in short vol, VOL. Now, example of this question, if I say there is a gas inside a container, we applied a pressure, the gas is there inside a container at 10 Pascal, and the volume of the gas originally is example 5 centimeter cube. Now what happened? We change the pressure, so as we change the pressure, what happened to the volume? The volume will decrease. But sometimes they ask, state what is the new volume or what is the new pressure. Example, the new pressure is, originally it was 10 Pascal, now we made it 30 Pascal. So the question is, what is the new volume? So how to solve this question? It is simple, P1 V1 equal P2 V2. So P1 V1 is equals to P2 V2. What is the first pressure initial? At the beginning, the pressure was 10 Pascal. What about the initial volume? That is 5. Final pressure, the new pressure, that is 30. What about the final volume? We don't know, so it's V2. So when we solve 10 multiplied by 5, that is 50 is equals to 30 V2, or 50 divided by 30 is equals to V2. So when 50 is divided by 30, 0 will cancel with 0. So it will be 5 divided by 3, that's equal to 1.66. So the final answer will be 1.66 centimeter cube. So the volume of the gas which is present is 1.66 centimeter cube. Is it clear? Discussion and the example of the Boyle's law, that how it can be used to calculate the pressure and the volume, or how it can relate the pressure with volume. And it is only valid for gases. So when you have a gas in the container, the starting in the beginning, the pressure is known as P1 and the volume of the gas is known as V1. When you change the pressure, the final pressure is known as P2 and the volume is known as V2. So P1 V1 equals P2 V2. The final result will give you the volume of the gas. Any doubt till this point? Another question, as you can see, okay, in this question, a syringe is there which consists of 100 cm cube of gas initially. So when they say 100 cm cube of gas initially, that is V1. And the pressure of the gas is 1 exponent 5 Pascal, that is P1. The volume of a gas decreased to 80 cm cube. So new volume is 80. We have to calculate the final pressure. So we'll use the formula that P1 V1 equal P2 V2. So P1, that is 1 exponent 5, V1 is 100, P2 we don't know, and V2 is 80. This 80 is multiplied, other side it will be divided, and our final answer will be 125,000 Pascal. Is it clear, this example question? So you just have to sort out the initial pressure and initial volume to work out the pressure exerted by the gas. So the topic 2.1, which is about the kinetic molecular model of the matter, is done. There are 3 topics for block 2, 2.1, 2.2 and 2.3. So we are done with 2.1.